Good morning. My name is Surakshi Bhomik. Roll number 34900323053. Department EC, third year, 6th semester. Subject name COMS VLSI Design. Today my topic is Operation of MOSFET. What is MOSFET? A metal oxide semiconductor field effect transistor MOSFET, a field effect transistor FET with an insulated gate where the voltage determines the conductivity of the device. It is used for switching and applying signals. The ability to charge conductivity with the amount of applied voltage can be used for amplifying of switching electronic signals. MOSFET are now even more common than BJT, bipolar junction transistor, in digital and analog signal circuit. The silicon dioxide forms the gate of the MOSFET. It is used to provide isolation by the preventing the direct flow of charge on the gate to the conducting channel. A MOSFET, it is the by far the most common transistor in a digital circuit as 100 for of 1000 of million of memory chip or microprocessor. Different type of MOSFET. MOSFET works in two modes: depletion mode and enhancement mode. Depletion mode. The transistor requires the gate source voltage VGS to switch the device. Of the depletion mode, MOSFET is equivalent to a normally closed switch. Enhancement mode. The transistor requires a gate source voltage VGS to switch the device on. The enhancement mode MOSFET is equivalent a normally open switch. Now, with respect to the working principle, MOSFET is classified as follows: P-channel depletion MOSFET, P-channel enhancement MOSFET, N-channel depletion MOSFET, N-channel enhanced MOSFET. P-channel MOSFET. The drain and source are heavily doped P region, the substance in the N-type. The current flows due to flow and positive charge holes, and they may who know a P-channel MOSFET, where when we applying negative gate voltage, the electrons present beneath the oxide layer experience repulsed force and pushed downward into the substance. The depletion region is protected by the bound positive charge which are associated with the donor atoms. The negative gate voltage also attracts holes from the P plus source and drain region into the channel region. N-channel MOSFET. The drain and source are heavily doped N plus region and the substrates in P-type. The current flow due to the flow negatively charged an electron, and that why known as N-channel MOSFET. Why are N why are we applying the positive gate voltage? The holes present beneath the oxide layer experience repulsive force and the holes are pushed down into the bond. Negative charge we are associated with the acceptor atom. The positive gate voltage also attracts electrons from the N source and drain region into the N channel. Thus, an electron-rich channel is formed. MOSFET working operation. The working principle, the working principle of MOSFET depends upon the MOS capacitor. The MOS capacitor is the main part of MOSFET. The semiconductor surface at the below oxide layer, the located in between the source and the drain terminal. It can be inverted from the P-type and N-type by applying positive or negative gate voltage. When we applying positive gate voltage, the holes present under the oxide layer and experience and recursive force, and the holes are pulsed and oxide layer experience repulsive force and holes are down with the substance. The depletion region populated by the bond of negative charges that are associated with the acceptor atom. The electron rich and the channel is formed. The positive voltage also attracts electron from the source and the drain regions into the channel. Now in voltage applied between the drain and the source, the current flow freely between the source and the drain and get voltage and controls the voltage. A whole channel will be formed under the oxide layer. Application: amplifiers, regulation of DC motor, construction of chopper amplifiers, switching and amplifying signal. And note a script to help the and your message notes can be added while your presentation and displayed into temperature present view will end this. Thank you.